Good morning. Good morning, everyone. My name is Joanna Pshala, and welcome to the second edition, second webinar in the WEkEO DIAS. We're very happy to see all of you, and we have some excellent speakers and experts in the field today with us. We will be introducing the platform to all of you and give you the first insight to the data and the tools available on the platform as useful for developing the applications for the coastal zone monitoring using the Copernicus data, as well as in particular the data of the Copernicus land monitoring service. Together, we will give you an overview of everything in this webinar. So you need to know all about the WEkEO DIAS services. And you have a thorough introduction also to the platform. And I hope you're all ready to dive in and to stay with us throughout the morning for the following 2 hours. And I'm very happy to introduce to you also our speakers this morning, starting with Mr. Orevich, Stefan Orevich, who is involved in the WEkEO user support platform as a senior advisor and expert. He has been involved in Copernicus user uptake activities also for more than 15 years so far, and is an expert in Copernicus market development and user engagement as well. Then we have Mrs. Anna Sousa, who is a Copernicus land expert at the European Environment Agency. She has a very strong background in Earth observation and geographic information systems. Working at the EEA since 2005 as a Copernicus expert. Mrs. Sousa is responsible for Korean land cover and the group of products included under the heading Priority Area Monitoring, the so-called Urban Atlas, and also riparian zones, LCLU in Natura 2000 sites, and now also coastal zones as well. Very good welcome and good morning, Mrs. Sousa. And then we have Dr. Jeff Smith as well with us this morning. He's a member of the WEkEO user support as a senior expert for land themes specifically. He has a very strong background in the fundamental interaction of radiation with vegetation and other surface materials. He works at the interface between users, service providers, and technology developers. He has been involved in the EO for over 3 decades so far, through academia, government research, as well as private sectors, and strong links to the Copernicus program as well, and the Copernicus land monitoring service. Last but not least, we have Mr. Amin El Amrani with us as well this morning, who is a satellite imaginary expert, and he is a WEkEO user support expert specialized in technical issues. He deals daily with users' issues, in fact, so he'll be very handy towards the question and answer sessions. We're gonna start with the introduction of Mr. Stefan Orevich, and as you can see in our agenda for this morning, we're gonna have the quick intro of the platform. Then we're gonna have Madame Sousa with her presentation on why are coastal areas so important, the Copernicus land monitoring service point of view, and a brief introduction already by Dr. Jeff Smith to the platform. And then we're gonna have a little break for 10 minutes, and we'll come back with the thorough introduction and live demonstration by Dr. Smith, and then we'll be taking your questions and answers. So we would really appreciate if you would put all your questions in the question and answer section, please. And the chat is deactivated for this morning. I think that without further ado, we can start and kick off this webinar, and I would like to give the floor to Mr. Urovich this morning. Thank you.
Good morning, everyone. It's pleasing to see people from all over the world. I see in the chat that we've got participants from India, from Italy, from Spain. It shows the interest that WEkEO in general and coastal zones in particular is getting quite a lot of traction. So let me share my screen. I believe you can see it. Can you confirm, Joanna, that it's visible? It is. Yep. Good. So I'm going to give you a general introduction to the WEkEO DIAS. What is a DIAS? A DIAS is a so-called Data and Information Access Service, and I will be giving you more details, but in a nutshell, it's a single access point to the Copernicus data, information, and services in the cloud, with both the data and tools to process this data in the cloud. What makes WEkEO special? Well, I would say in particular its shareholders, the institutions that have decided to work together to develop this unique platform. As you can see on the slide, they're the European Organization for the Exploitation of Meteorological Satellites, EUMETSAT, the European Centre for Medium Range Weather Forecast, ECMWF, Mercator Ocean International, and the European Environment Agency. Why is that special? Well, because these four partners are basically the most important data providers in the Copernicus ecosystem, together with, of course, the European Space Agency that manages some of the satellite data feeds. The entire architecture is managed by these partners, while all the implementation is contracted to industry and to expert players in the field. Another special attribute of WEkEO is its distributed infrastructure. This distributed infrastructure basically builds on the existing network that enables the data of Copernicus to already be available from the various satellite sources, from the various services. In this particular case, there is no duplication of the data. It's the native data which is already resident on the servers of the various partners that has been networked basically and made accessible. This ensures, of course, speed of access. This ensures that you always have access to the most up-to-date data, because there's no need to go and copy it from somewhere else or to download it. And because you are dealing with a service that is proposed by the custodians of this mass of Copernicus data and information, you're also certain that these data will remain available for a very long time period, because there is no question about the sustainability. The future of the DIAS is guaranteed for a minimum of 7 years. An agreement was signed with the European Commission last winter or autumn, I believe, and you also have the guarantee that any new product that would be introduced in the Copernicus product portfolio would be immediately made available through WEkEO. So what is WEkEO? As I said earlier, it's Copernicus data. It's an environment, a virtual environment in the cloud, with both data and processing, virtual machines, graphical GPUs, etc. And very unique feature of WEkEO, an expert user support. Indeed, who better than the European Environment Agency, for instance, who's responsible for developing the Copernicus Land Monitoring Service, who's better placed than them to support users when it comes to questions relating to the data and the information that is available within the Copernicus Land Monitoring Service, which we usually refer to as CLMS. The main assets, as I said earlier, it's not a copy, it's the original. This expert support is obviously very important, and also a completely harmonized data access that ensures the seamless availability of the data throughout the product and information catalog of Copernicus. And I'll come back to it, some Jupyter notebooks, desktop. You can use either Jupyter notebooks in the cloud. You can download the data and use it in either proprietary or in open source tools such as Qgis. We'll talk about that today in more detail. It's basically, there's no limitation whatsoever, no proprietary format, etc. Because obviously, as you may already know, the Copernicus data and information is accessible on a full, free, and open basis, which also means that the tools to use it must be as open as possible. WEkEO is not targeting any particular category of users, and we're really trying to serve both the scientists, the students, the researchers, the private sector to develop applications for the public or for their own operations, institutional bodies, agencies of the EU, Directorates General of the European Commission, the Directorate General for the Joint Research Center, but also because it has these very nice viewers that allow you to discover the data, to basically look at satellite data in a very easy manner that obviously does not require any prior Earth observation, remote sensing, IT, GIS knowledge. The data catalog. The data catalog basically includes all the satellite data, at least in its level 1 and level 2, so the baseline products, and most of the data sets available from the various Copernicus services, at least the ones accessible on a full and open basis. So, for instance, obviously you won't find products from the security service in WEkEO, but all the other products, or most of the other products, are available. It means the data from all the Sentinels, Sentinel-1, Sentinel-2, Sentinel-3, soon Sentinel-5P, the atmospheric compositions satellite. Soon also, it's in preparation, the data from Sentinel-6, the radar altimetry satellite of the Copernicus constellation that looks at sea level rise, as well as the products of 4 of the services: the atmosphere monitoring service, the marine monitoring service, the land monitoring service, and the climate change service. And for this, you have an infrastructure to store your products or your applications, to process, even as I said, graphically, etc., with tools. You have quite a very large corpus of documentation, wikis, FAQs, etc. The high-level support that I mentioned earlier, where we have a very strict service level agreement for which we are obliged to answer questions from users and from the public in a very short time frame, and a marketplace which enables people and companies and startups and entrepreneurs who have developed interesting applications with Copernicus data on WEkEO to advertise basically their product or their application. The catalog, last time we looked, comprised 309 datasets. And again, these datasets pertain both to atmospheric composition, to land monitoring, both at global, pan-European, and local scales. It includes the data also of the Marine Copernicus Marine Service, and the data from all the satellites that I previously mentioned. As I said, there's this beautiful and really easy to use. I mean, personally, I have a political science degree, not a so science, yes, but political, not, and I can really use it easily to look at the particular situation or just wander around the world. And here you have, for instance, here you see that ship that got blocked in the Suez Canal. Well, you can go and look at that scene and any other scene available in the data catalog without any specific knowledge or training. The user support. We basically offer, as I said, quite a lot of dedicated documentation. There's 2 levels. There's a level 1, which is, I would say, the simple questions that are answered by a dedicated team. But the level 2 relies on senior experts such as Dr. Smith and also colleagues from EUMETSAT, from ECMWF, from Mercator Ocean, and from the European Environment Agency, that is basically able to answer any question. I mean, I've seen questions that I didn't even understand. I didn't understand the question, and obviously couldn't understand the answer. So we can go rather deeply into explanations and support to the users of the WEkEO DIAS. Quite a lot of data and information on how to use the system, troubleshooting, FAQs, etc., is available on the website. There's also, and that's important to note, there's an API which enables to automatically milk the data basically from the system to use it in your own applications. So rather a very complete offering that normally should meet all kinds of user needs. And as you can see, at least more than 50 FAQs. So you should normally find your answers. And if you don't, the easy thing is to send an email to support@wekeo.eu, and you'll get an answer within less than 5 days. There's a YouTube channel also on which all the webinars and training sessions that we have delivered in the past are recorded. So you can, it's quite a wealth of information with demos, with practical examples, with information on the Jupyter notebooks that are available on WEkEO and can be used for training or for working by the example purposes. So these webinars and training sessions that we're delivering, some of them are generic and present the IT infrastructure, how to set up a Jupyter notebooks, how to develop an application, and some are thematic like today's, and they aim at giving a highlight of a particular application. And today, obviously, we're going to be talking about coastal zones and coastal monitoring. But you already have 39 videos available, so quite a catalog that you can browse through. We also are present on Facebook and Twitter, and you can also try and ask questions through that channel and find information about release of new products into the catalog, future seminars, webinars, competitions, etc. that WEkEO organizes. There's a page dedicated to support. You can either fill in the online form or send an email. Pricing. Most of the offering is for free. You can register for free. You can search for data for free. You can view, discover, download data for free. You can promote your business or your application for free. The only thing that you have to pay for, because it has a cost, is computing power and storage space if you want to develop something on WEkEO. So quite a large free opening. And to be noted, if you want to play around and use Jupyter notebooks, that's for free. And there's quite a number of them in the Jupyter Lab section that you can use and you can try. The plan. So what makes the difference with the payment is the virtual machines, the processing tools, etc. As you can see, there's quite a lot of different plans, paying plans, depending on the amount of memory you need, the RAM, the storage, and the number of, if you need GPUs or you don't, etc. To be noted, the trial periods are quite generous. 5 months for €0 for the light version, and for applications of particular technical, scientific, or societal interest. I do know that our colleagues from the commercial department are flexible and very often willing to extend the trial period if the application at hand is like really interesting and impactful and that either solves a societal problem or demonstrates the usefulness of the WEkEO DIAS. There's a rather extensive Jupyter Lab where you can write Python code. You can there's quite a good GitHub infrastructure around it, and it's a very good tool for training and for discovering the way that the DIAS can be used. There are 2 dedicated tutorials, one on getting started and one on the IT infrastructure, which if you want more details, you can view on our YouTube channel. So we hope you will join our community for those who are or not already registered, etc., and that you will find interesting today's presentations on coastal zone monitoring using Copernicus, with special focus on the coastal zone datasets of the Copernicus Land Monitoring Service. And obviously, if you have any questions on these general items, we'll be glad to answer them in the Q&A session that is planned later in today's agenda. Thank you for your attention.
Thank you very much. And everyone, without further ado, we will move on into presentation of Mrs. Sousa, right? Yes. Why are coastal areas?
I was
Yes.
trying to.
Hi, good morning. Lovely, it's working. Lovely. Yeah, so you can go ahead and try to share your screen with your presentation, and the floor is yours.
So can you see it, I suppose?
Absolutely, thank you. Lovely.
Thank you. So good morning, and it's almost good afternoon. I have been asked to present to you the EA's point of view regarding monitoring of coastal zones. Why are we interested in coastal zones, and why are we implementing the CLMS, or Copernicus Land Monitoring Service, coastal zone product? Yes. So coastal zones, what are they? They sit at the interface between sea and land, and we can look at them as a sort of continuum. There's no really hard line that states where it starts, where it ends, but we know more or less where it is. When we are at the beach and we feel we are in the land part, we feel hot, and then we go into the sea. Europe's coastline is estimated to stretch almost 185,000 kilometers, but this was a number taken some years ago from the Korean land cover data set. I'm not sure if it's fully correct. Coastal zones are very important for Europe's economy. We have approximately 40% of the youth population that lives within 50 kilometers of the sea. And almost 40% of EU GDP is generated in these areas, in maritime as well. And 75% of the volume of EU foreign trade is conducted by sea. So we understand that there is a lot going on, but this also brings a cost to the environment. Marine and coastal areas are under pressure. We all know that. It's well known. Coastal areas are among the most populated areas in the world, and this means that they are subject to increasing pressures from what? Population expansion, tourism, shipping, resource extraction, on and offshore wind energy production, exploitation of natural resources by certain activities as well, such as aquaculture, fisheries, and the associated overexploitation that we all know about, agriculture, and the list goes on and on. Of course, this leads to inevitable conflicts between the different interest groups and also competing interests, of course, what human development, right? So we face and we witness deterioration, and this results in destruction of habitats, in pollution, loss of biodiversity, vulnerability to natural hazards, such as storms, floods, erosion, sea level rise, a striking consequence of climate change, and acceleration of coastal erosion. So these areas have high value for people, high value for nature, and then therefore we need to monitor the pressures on the natural resources and on people. From a DEA perspective, where did it all start? It all started back in around 1994 when the EA was established as a European agency. And in our regulation, our founding regulation, one of the priority areas of work is coastal and marine protection. So over the years, a lot of work has been done in this area, and I will show you a few examples. From 1997 until 2000, we published annually the Marine and Coastal Environment Annual Topical Update Report. In 2000, the agency published the state and pressures of the marine and coastal Mediterranean environment that was also annually updated for a period of time. Then the work on defining indicators started in 2002, which resulted in a report about, as you can see in the title, testing of indicators for the marine and coastal environment in Europe. In 2003, we published a briefing about the continuous degradation of Europe's coasts and the threats to our living standards, if I might call it like that. In 2010, the State and Environment and Outlook report dedicated a whole section, or a whole publication to the marine and coastal environment, which was then also addressed in the reports published in 2015 and 2020. And as well in 2010, to celebrate the Year of Biodiversity, we published a summary report containing 10 messages dedicated to coastal ecosystems. And then in 2013, the report about the need for a knowledge base for integrated management of our coasts. And this is when Copernicus came into play. In the Copernicus work program of 2014, it was stated that Copernicus should start, and I quote here, the preparation of a service to monitor the evolution of man-made activities reflected in changing land cover and use patterns in coastal zones in the framework of integrated coastal zone management. And then this was afterwards echoed in future Copernicus work programs, but those work programs very specifically called for CLMS and CMEM, so the Marine Service, to develop a pan-European service for monitoring the coastal zone and identifying vulnerable littoral ecosystems. So we clearly need a sound information basis to facilitate our work on maritime spatial planning and integrated coastal zone management. And that is why we are now developing products designed for the coastal zone within CLMS and working in collaboration with CMEMS, the Marine Service, addressing different aspects of the coastal environment. So EEA deals, as you can see in the slide, with the land side and the MOE, so Mercator Ocean International, the entrusted entity for the Marine Service, deals with the marine side. So these two entrusted entities have agreed to a roadmap for collaboration, and work is in progress in several fronts. So from the land side, from the entrusted entity EEA, the first product that was produced is the land cover land use product. You can see an excerpt here. It covers all European coastal territory and with an inland depth of 10 kilometers. We had to decide where the coast would start and end. So we chose the 10 kilometers, which is a value more or less agreed among the community. And the product covers approximately 730,000 square kilometers. But in some areas, it has to go a bit further than just the 10-kilometer strip, because we need to cover also important land features surrounding, for instance, as in this case, you can see surrounding the estuaries. The product has a minimum mapping unit of half an hectare, a minimum mapping width of 10 meters, and offers 71 land use classes. And we have already some kind of a time series. We have data for 2012 and we have data for 2018. And as you can see in the graphic to the right, between 2012 and 2018, there was a huge increase of artificial surfaces in coastal zones. And I'm referring to the orange column. We found out that because we could do the assessment based on the 2012 and the 2018 data set. In terms of nomenclature, which was it's a dedicated nomenclature to coastal zones, I have to say that it's, I would like to say it's compatible at level 3 of discrimination with, I hope, the well-known Marine land cover product, but it goes further down to level 4 or even 5 to provide more detail in certain classes. So as you can see here, for instance, at level 4, no other product provides this kind of information. Within level 3, port areas and associated land, we discriminate between cargo ports, passenger ports, fishing ports, naval, marines, and local multifunctional harbors. So, and I have another example. I'm not showing the 71 classes, just examples. For instance, at level 5, we were requested to separate sandy beaches from shingle beaches. So this is for the nomenclature. I would also like to state and stress that CLMS has more to offer than just the coastal zone products. Before Copernicus era, several products already included information about the coastal zone. And here I am talking about, for instance, core inland cover that supported much of the EA work in the past, some of the reports that I mentioned previously. Then we can also add the high resolution layers. We have imperviousness, we have forest, grassland, water, and wetness that added more detail to the CLC polygons and allowed us to make finer analysis. But we also have urban atlas with more detail than coastal zones because it goes down to 1/4 of an hectare in urban areas, and it covers 24% of the coast. Riparian zones also cover 6%, and then a few Natura 2 sites located at the coast also have been mapped and cover around 1% of the coastal area. I would like to finish by summarizing the important features of this product. We have full coverage of coastal zone across Europe, 10 kilometers landward, adjusted area of interest, as we adjusted in the area of the estuaries, for example. We have sufficient spatial detail, a very high resolution. So this is a product based on very high resolution satellite imagery between 2 and 4 meters. It has 1/2 hectare minimum mapping unit and the 10-meter minimum mapping width. The thematic needs were addressed in a tailored nomenclature that goes down to 4 or even 5 hierarchical levels with 71 classes. The change detection 6-year cycle, but we are exploring, so in 2012, 2018, we have a 6-year cycle, but we are exploring options for a 3-year gap between the inventories, or even an option for more continuous monitoring in particular areas, but this is not yet decided, but it's being thought. We're also looking at evolution for monitoring seasonal changes such as coastal erosion, sediment transport, phenology, pollution. So, and to conclude, I would like to stress that integrated and ecosystem-based approaches provide a foundation for sustainable coastal management and development, supporting biodiversity, ecosystem service, but also the socio-economic development. The coastal zone product provides the necessary knowledge base, but there's more to be done, as always, right? We need coordinated action at global, regional, and local levels, which is key to sustainable management of coastal ecosystems. Now I leave the room. Thank you very much. I leave the room for more interesting and exciting practical sessions and live demos that I am as well very eager to forward to look into. And to be honest, I really need someone to tell me to best use WEkEO. Thank you very much.
Thank you so much for this very thorough overview and your presentation. Thank you so much. And now we're going to move on into the practical session, as you've just mentioned, and the introduction by Dr. Smith. And just before we jump into that part, I would like just to tell to everyone and all the participants, because we had one question about the issuing of certificates of this webinar. You can go ahead and send an email. If you need a certificate, you can send an email to wekeo@spacetech.partners. I'll put this email also in the chat box. And the floor right now is Mr. Smith, thank you so much. You can go
Hello.
ahead. Thank
Good
you.
morning, everyone. I'm just going to get my presentation rolling.
Yes, thank you.
Okay. Let me just sort this out.
We've just seen your screen, but then it disappeared. So maybe you just want to share again.
Yeah, I'm just trying to, here we go. Yeah.
Yeah.
Okay.
We're looking forward.
Yeah, no, it's coming. Here we go.
Thank you.
Okay, sorry, I'm ready to start now. Can you see my presentation display mode?
All great.
Great. Okay. Sorry about the delay, everyone.
No worries. No,
okay, I'm going to give us a demonstration now of some of the things we can do with Earth observation and coastal zones, and then I'm going to look at the give an example demonstration site. I'm going to talk about a site I've been looking at in called North Bull Island in Ireland, and then I'll show how we can access some data for that site with WEkEO. And then after the break, then we can talk about how we could use that data in Qgis, and I'll give you some example analyses that I've performed and that you can then copy and use in your particular locations. And we'll finish off with conclusions and questions and answers. So Earth observation and coastal zones, as we've just heard from Anna, this is a really important environment, this interface between land and sea. And because of this, we have a really complex overlap of both terrestrial and marine processes. And these processes have cross-domain impacts. So, I mean, the obvious ones are things like the waves crashing on the shore from the ocean, or the marine side will then influence the distribution of different habitats and land covers on the land side. And these processes are driven by a whole range of drivers from things like the winds and storms generating waves. We have currents that move water around the globe and then have an impact on the coast that they pass alongside. On a daily basis, the tides change and our view of the landscape in the coastal zone changes as part of it is inundated, is covered by water. And we also have issues related to climate change, such as increased sea level, and how that will then impact on the land domain. And also this climate change will also potentially increase storm frequency and severity. So some of these processes may be becoming more intense. And then from the land side, there's also drivers for development. As Anna said, there's large populations living in the coastal zone. Land is taken for different human activities, and it's also agriculture and all these types of things, and even protected areas where we wish to maintain different habitats. So very complex situation with lots of drivers. And these highly dynamic processes can range, as I said, everything from a single wave crashing on the beach to the reshaping of coasts that take place over centuries. And so some of these processes are linear and continuous. Some may be cyclical and will change with the seasons or with the monthly tidal cycles. And other things are going to be episodic. So the impact of storms could have a dramatic change of a landscape or a land situation over a very short period of time. So when we want to monitor these types of landscapes, we're actually faced with quite a few major challenges. And because it is so dynamic, one of the important things we need to try and do is to create a synoptic view. So this is a view of a large area, an understanding of what the situation is at a particular point in time. And you can imagine if we're doing that with field-based methods, it's very difficult then to get into the coastal zone or measure features along the coast at one instance in time. And you can see from that little picture there of some people on a mud flat taking some measurements, and the requirement there for taking a boat which took them out onto the mud flat and then landed when the tide went out. So it can be quite a challenge for organizations and organizational activities to actually take those measurements, and therefore there's extreme costs as well. And many of those areas, such as those mud flats, are actually highly sensitive areas. So you have some of them may be important habitats, which take a long time to develop, and so repeated visits of people on the ground taking measurements can also create a large amount of disturbance. We have lots of subtle changes both in time and in space, and so we need detailed temporal and spatial mapping to appreciate them. And the bottom right image there is just showing this coastal zone there, and the yellow dots represent point measurements that were taken for a particular survey. But as you can see, lots can happen to the coast between those point measurements, spatially and temporally. So that's where satellite Earth observation comes in. It gives us a great opportunity for monitoring coastal zones much more effectively. So we have regular acquisitions. The satellites come round on their orbital paths every few days, depending on, or every few hours, depending on the satellite type. And each time they cross over, they cover a large spatial area. So it's not just a point sample. The image in the bottom right there is a Sentinel-2 scene for North Germany and the Wadden Sea. And that was taken, that's a subset of one image. So you can see the extremely large areas that can be acquired. And that then gives us the power of generating these synoptic measurements. So we have a view there of what the situation was along that entire coastline at one point in time. And when we go down to spatial details of 10 meters or better, we can then start to get the amount of spatial detail that is important for characterizing these complex situations. And because these satellites are in orbit and operational, that this coverage is then collected systematically, and there's no need for additional surveys to be organized, etc. These measurements will be taken at regular intervals, and the end user can then just sit back and wait for those measurements to be taken. There's going to be precision and accuracy issues when we're measuring things remotely compared to measuring things on the ground. And we know that can be a problem. But what we have to do is think about the trade-offs. So if a measurement is taken on the ground at maybe 100 points, with very high accuracy or precision, but with a satellite image, the accuracy may be lower, but we can take tens of thousands, hundreds of thousands, or even millions of point measurements and repeat those at regular intervals. So when we're dealing with monitoring the coastal zone, we have to think about the potential trade-offs with the measurements that we're making. So I'm going to use an example in these presentations. It's a place called North Bull Island. And if you look at Europe there, if you know where Ireland is, there's a city there, the capital of Ireland, called Dublin. And if we zoom in here, hopefully you can see my mouse working. Here's the city of Dublin in grey here. And the river that runs through the middle of the town is called the Liffey, which then connects to a port here. And and Dublin Bay is where the river flows out into here. And what we're going to look at is an area called North Bull Island here, which is a sort of sand spit which exists in the bay here, which has a really interesting history of how it came about and what it's been used for, etc. So just to give some more details there. So North Bull Island, it's 5 kilometers long and 800 meters wide. And you can see from that rather nice aerial photograph there, there's very little development there, although there are actually 2 golf courses. But it's a combination of sandy beaches, sand dunes, and salt marshes. And you can see, you can just on the right-hand side there, you can see the sandy beach, and then sand dunes, and then these golf courses, and then salt marshes, and actually some mud flats as well on the inner side there. It's an important site. It's used for leisure activities, as I say, golf courses, and it's actually one of the most protected sites in Ireland for nature and conservation, and it's a really important bird reserve. It's also a UNESCO Biosphere Reserve and a Natura 2000 site. So there's lots of different conservation and habitat activity going on there. Although it appears quite natural at its northern end, there's a very hard straight line at the southern end, but the actual island itself developed due to human intervention. So activities that human development in the coastal zone actually caused North Bull Island to form. It has this very interesting history, etc. And if we go back in time to 1776, here's a very old map here. The map was drawn without north at the top, if you see. So I've had to rotate it to place north at the top of the thing here. And so what we can see here, here's the River Liffey coming through Dublin, and this is where the harbour developed here, and the port facilities. And at this time, there was a single sea wall going out, which was hoping to guide the flow of the river here to maintain a navigable channel into the port. But it was found over time that this channel was still silting up, and so there was a necessity to build a second wall. And so we can see on this slightly later map here that we have this second sea wall coming out from the coast here. And the beginning, sorry, if you look on the first, go back to the first map, you can see that North Bull isn't called an island, it's just called North Bull. And it's actually just a shallow area of water, sort of mud flats, sand flats, etc. area there. But after this second seawall was built here, then increased sedimentation on the north side of it started to increase the elevation of the North Bull area, and then it became vegetated and then effectively became North Bull Island. So this island is it's been created by human development, but is actually now an important nature and conservation site. And the examples I'm going to talk about later. First one is around kind of sea defenses and the issues that are happening with increased storm frequency and sea level rise, and how we can exploit some of the Copernicus Land Monitoring Service data there to help support some of the analysis that will go into where the sea defenses need to be placed. And the second example I'll show is how we can take the Copernicus data and some Sentinel imagery and then combine it to start to look more at the more detailed spatial patterns in the coastal zone and move more towards the habitats that are being reported here in this very detailed study that was performed by drones at North Bull Island. So now I'm going to quickly, we'll look at some data within the WEkEO system, and then we'll look at how that data is derived from the various services that are on offer within Copernicus. And then after the break, we'll then look at Qgis. So we'll start to take some of that data that I've downloaded from WEkEO, and we'll do some processing and show some results and analyses and how we can move forward with developing applications in the coastal zone. So I'm now going to swap over to WEkEO, and so I'm going to do a live demo now. So hopefully my screen has changed now to the WEkEO website. This has already been shown by Stefan at the beginning, and I've already logged in here. So if you've not used this site before and you wanted to access data for free, as Stefan said, you'll need to log in, and then you get this kind of dashboard display here. But I'm going to use it today just to show you some of the data sets that are available from WEkEO that we can use in the coastal zone. So I'm just going to clear these off now. So when you get into the application, you're shown this world map, and you're able to then, with simple mouse controls, you can zoom around and find your area of interest. And what I'm going to talk about now is I'm going to quickly do an overview of some of the things that are available from the marine side, effectively, or the marine and atmospheric side, that can be used as important inputs when we're looking at the drivers of coastal change. And I'll be giving some examples that were actually spoken about in far more detail in last week's, the previous webinar, where we looked at renewable energy applications based on Copernicus data. So I'm going to just show you them briefly, but if you want more details about those, then please go and look at the previous webinar. So when we look at our viewer here, we have this button here with the plus sign for adding data sets, and Stefan was correct. There are 309 data sets available there. And what we can see is that they are categorized under various headings here. So we have the various services, and then the various satellite missions, Sentinel-1, 2, and 3 are there. And then a range of other tags that may be present on the data sets further down. So first of all, we're going to look at a CMEMS data set, so it's a marine data set. And this is one, if you're considering waves and storm issues, then this is a really useful data set. And so I'm just going to quickly scroll down to this one. Maybe I'll just search for it. Whoop. Spell. Okay. Get the right name. Typical when you're doing a live demo. Hold on. Okay. Okay, sorry about this. Okay. Ah, here we go. Sorry. Oh, it's down here. Yep. So I've now gone and found this sea surface wind wave significant height product. And I've now loaded it in. So this has given us information on the wave heights on the ocean. So this will tell us something about the energy or the dynamism of the coast, of the waters on the coast, and therefore we can read into this how much damage or erosion or sedimentation, etc., will occur. And these data sets are modeled, and we can actually then change the time slider on here to show that these that the conditions change over time. So the blue values are very low wave heights, and the red and orange values are very high wave heights, and we can see over time that they change. And we can you could take these out and use these in order to drive your application. Another data set is available from the climate service, and okay, just sort this one. Okay. Okay, we can, and this data, even though we can't display it on the map, we can actually download it. And if I click on the download button here, you'll see that there's a huge amount of variables that you can then pull out and then extract. So this will give us wind directions and wind strengths, etc. And these can be downloaded and extracted and also added into your models. So we can actually take both the water information and the atmospheric information and use that for driving your applications. So I'm just going to delete those two. And what we're going to do now is, if we zoom in on Dublin Bay, I'm going to just give you show you what more information is available there. And one of the ones that's already been mentioned quite a lot is the Careen map. And this is a famous product for Europe, which goes back to the 1990s, and there's been multiple updates. And we can see here that this is a land cover land use map. This one has 44 classes, but it only has it has a minimum map of unit of 25 hectares. So that's not overly useful when we're dealing with the very narrow coastal strip. So you can see here that this is a very generalized view of what's happening in the coastal strip. So that's why the EEA moved ahead with the development of the coastal zones layer. And so I'm just going to add that to the map now. And so you can see as that draws over the top that we now have far more detail in this coastal strip, and we can then use this for doing much more rigorous, but spatially detailed updates and analyses. So, and then once we have these data sets identified, you can see here that we can compare them in WEkEO, and this viewer is quite a powerful tool for overlaying data sets and comparing them. But we can also download as well. So I won't do any downloads now because it's going to take up bandwidth, and I'm trying to run this presentation. So that's the sort of the thematic information that we can use in the coastal zone. And I'm going to just add one more data set just to show you, and that's going to be a satellite data set. So if we go to Sentinel-2 now, and we add that as a product, and just to show some difference, we'll add the false color version of that. And you can see here, here's an image of Dublin Bay in false color infrared format. So the red here is vegetated surfaces, and as we zoom in, you can see the darker surfaces are the water, and then in the port here, the bare surfaces are coming out grey. But this shows that this data is also available to download, and we can move the time slider here and choose different temporal areas, and we can also set areas of interest. All of this this process is explained in more detail in some of the earlier webinars, so I'm just giving you a quick overview. I just wanted to show that we can make all the data that you may need can be made available within the WEkEO service, and that then you can access and download it. And again, I won't download this. I can set up minimum bounding boxes and time stamps, etc., and different processing levels before I request the data. But we can't. I won't do that now, as it will take up time. And I think we've also reached the point where we've got to the break now. So after the break, I want to come back and talk to you about how I can use some of this data that I've just shown you in WEkEO. I've downloaded it and make it available in Qgis, and then we can process that data and come out with some useful information that we can then use for coastal zone applications. So I'll leave it there, and we can now have a break, which I think lasts for 10 minutes. Is that right, Joanne?
Exactly. Thank you so much for this excellent introduction. Fascinating, and we're all looking forward to the in-depth demo presentation after the break. So I would like to invite you all for a 10-minute break. Get yourself a great cup of coffee or tea or water, and we'll see you right at 28 right now. I suggest how about 1 p.m. That's correct, no, Jeff? What do you think?
Yes, that's fine. Yeah, or 20. Yes, 22. Yes, fine.
22. See you all in 10 minutes. Yes.
Okay.
Thank you. Hello. Hello, everyone. Hi, Jeff. Oh, can you unmute yourself? And
Hello.
hello, everyone. Good morning again. And we're right back after the break. Hi, Stefan. Continuing with the in-depth demonstration by Dr. Jeff Smith. We're really looking forward.
Okay, great. Okay, can you see my screen with a map view on there?
Absolutely, yes.
Brilliant. Well, welcome back, everyone. Thanks for rejoining us for the second part of this webinar. I'm now going to work through some analysis examples based on Qgis, which is a free and open source geospatial analysis package. Many of you may already use it, but if not, it's available at qgis.org. You can go to that location and download it and install it, and it's a very straightforward process. So what I've done here is I've installed this, basically the standard QGIS version, but for this analysis, I've just added a few additional bits of functionality. And this is possible within QGIS by going to the plugins section here, which then allows you to manage and install plugins. And so here we have a huge list of additional functionality that you can load in there. And I've already loaded in some tools for analyzing vector data sets. So I've added in this group stats application or functionality here. And also looking at raster data sets, I've also included raster statistics. So this is just additional functionality, which is, again, free and open access, and you just install that before you get going. So that'll just help me to do some of the things that I want to demonstrate in this application. So as you can see here, I've just got an OpenStreetMap view of Dublin on the screen, just to give us some context. The main part of the city, the docks, and there's North Bull Island again now. And also within many of these GIS applications, you also have image layers as well. So here's an image layer, and we can zoom in and look in more detail at North Bull Island there. So we can, it's just refreshing. So we can then start to think about how we will take our analysis forwards. Just waiting while that refreshes there. Oh, there you go. And so what we want to do today is, first of all, is to use that coastal zone product that Anna talked about and I showed in WEkEO. And this product, as we could see from the earlier slides, actually covers the whole of the coast around Europe. But I've actually just pulled out a small subset for this demonstration, just to make life a bit easier and prevent perhaps the application from struggling too much. But I've got this little subset here. And so what I've done here, I've displayed it with its standard color table, but I've also allowed some transparency so we can look through to the underlying layers. And I think you can easily then make out how these different classes operate. So we have these, the red classes here are different urban areas. And if I, let me just pop up the nomenclature here. So we can see these urban classes at the top here in red and shades down to orange here. And they're showing us where different densities of residential housing are, and we can see those street patterns within there. When we get to the purples, we look in the sort of industrial areas. So these are small patches of industry. And then the lighter colors are the port here, etc. So, and then there are some purples which relate to the intertidal habitats there as well. So I'll just close that. If you remember back to when I was talking about North Bull Island and some of the issues there, there was this issue of flooding and potential storm damage around an area called Clontarf in Dublin. And if I just add on a layer which shows the area of Clontarf here. So this is, apologies to anyone who actually lives in Dublin. This is my rough digitization of the area, but this is approximately the area referred to as Clontarf. And we can see that some of the area is effectively behind North Bull Island, and some of it is open to what effectively is the open ocean here. And because of the shape of Dublin Bay, we can see that the main direction for the waves will be coming in from this sort of southeasterly direction and impacting on the coast along here. And you can see therefore that North Bull Island is effectively acting as a natural sea defense here. The waves will break on North Bull Island, take away their energy, etc. Whereas to the west here, the waves will continue on and then break and build up along this coast here. Very close to this red, there's a small area of grassland just fronting the coast here, but behind that you're straight into residential buildings, etc. So what we can do is using very simple processing within Qgis, we can actually then pull out just the area related to Clontarf, and we can do that by just a simple clip function. Let's move that onto this screen here. So we can actually set up, so we have the input layer here as being the Coastal Zone 2018 product, and then we can then clip that just with the area of Clontarf. So that's that blue line running around there. I won't run this process because I've done this already, and everything I'm going to show today I actually did in QGIS. It's just that I have the layers saved just in case of any technical problems, and so that prevents us from having problems having to restart applications, etc. And so I'm now going to, so the area we clipped out of the main coastal zone layer now just clipped out by that blue boundary, and we can now zoom in and take a look at that. So I'm just going to switch off the bigger layer, and then we can, whoops, and then we can then zoom in on the Clontarf area. So we zoom to that layer. So we can see here that we have a pattern of landscape features. The greens are the more grassy vegetated areas. Some of these are urban open spaces. Some of them are grasslands, etc. And then we have this red area, which is mainly a kind of what we refer to as a medium density residential area. So what we can do is very simply, but we can categorize that whole area very quickly by then just running some group stats on there. So if we go back to the this group stats plugin here, we can load into that area. Oops, let me get the right layer. So we want to look at the Clontarf area here. So we can load in the different class codes. So we could say use class 4, and then we can what we want to do. We want to use the area of those objects here. So we're going to move that into here, and then the process we want to do is we want to sum them. So for each class, we want to take each object. We want to find out its class, and then add all of the objects of the same class together to calculate a kind of a histogram of the proportions of different land covers within that area. So if you run calculate here, you can see that we've actually got what's that? That's about 11 classes are present in there out of the 72 classes of the 71 classes of the coastal zone product. We can see we have those 3 levels of urban density here. We have some industrial, and then we have this kind of sort of port facility type stuff, and then we have a little smidgen of coastal zones there, and then I think that's water, I think, down the bottom there. Okay, but what I've done already is, so I've taken this information from here, and I've transferred this into a table. So it's a slight cheat, but I'm just going to show you the data there. Those numbers are exactly the same as what we had before, and so for those classes, you can see in more detail now are the 3 different urban densities. The majority is this medium density residential here. So we have industrial, commercial, some rail and road networks, a class called no current use, which is sort of like brownfield site, abandoned land, urban green spaces, a little bit of managed grassland, some intertidal flats, and then some modified water courses. So that's the sort of the river channels or canals of that area. So we can look at that, and then very quickly it gives us an idea of what sort of land we are, which potentially at risk across the whole of the Clontarf area. So it's mainly commercial, mainly medium density residential. There's quite a bit of green space, which is good because that's less that can be less damaged by flooding events, etc. But there is, you know, a significant amount of industrial and these rail and road networks as well. So all of these things could be potentially damaged by a wave event, and if there was not sufficient flood protection, etc. Excuse me, along that coast. So that's the area as a whole. But as I'd already mentioned, part of this area is actually protected by North Bull Island. So we can actually do a different analysis. We can actually say, okay, well, why don't we then break up the Clontarf area into two separate zones? So if we have Clontarf East here, so this is, again, this is all done from my own interpretation. So apologies to anyone who's from Dublin. And then I chose an area I refer to as Clontarf West, which is this area here, which is, so I've kind of roughly, using the road network, digitized a boundary between these two areas. So we can see what area here is potentially exposed to waves directly hitting the shore, and then what area here is effectively protected by the presence of North Bull Island. And of course, we can then do that. We could do that same analysis that we did with the group stats. We can do that again for each of those sub areas of Clontarf East and West. And so I've already done that, and I've copied over the values into this table. And so what we do, if I kind of if I just highlight those again now, what we can see here now is we have slightly different distributions for each of those areas. So don't forget, Clontarf East is the one that's protected by North Bull Island, and that has a kind of lower proportion of residential area compared to the urban green space. So even though that's the most protected, but in proportional terms, there's actually less areas which could be damaged, or you kind of less higher value areas are present there. And if we look in the western side, then we have a much greater area, that residential, which we can kind of see visually from the map, but also here it just gives us quantitative values. Because if we were then to model this and model different storm events and different water surface conditions, etc., from the other, by using the other Copernicus layers from the Copernicus Climate Change Service and from the Marine Service, we could do that modeling, find out what the flood extents are likely to be, and then we can compare those flood extents to this type of information to tell us what proportions of properties, etc., and their values, or what types of industrial features, etc., are at risk, etc., in this area. I mean, a good example here is there's actually no rail network in the eastern portion, but there is in the western portion. So if you're concerned about maintaining the rail network in the event of in the event of a storm happening, then you know, it's important to know which areas that you want to protect there. So that's a relatively simple way of pulling out quite complex set of information from these from this data set. And as I said, if you were to model this area, maybe include elevation data as well, you could actually then subdivide the region up in different ways when you're doing things like estimating flood depth, etc. And then use this base data of general land cover and land use in order to categorize what areas are at risk and therefore need protecting. So that's the effectively the end of my first example, and we can take questions about this later on. So I'm just going to switch off some of these layers here. And so, as we said before, Careen is very generalized. The coastal zone layer is actually more detailed, but it's still not quite as detailed as the satellite imagery. And so what I've done is I've taken an image that I downloaded from WEkEO, and I've loaded in the 10-meter bands. If you're familiar with using Sentinel-2, it has 4 10-meter bands, and then a set of 20-meter bands, and a couple of 60-meter bands, which are used for atmospheric correction. So I'm just looking here at the 4 10-meter bands here, and this is looking at it in a general kind of a true color format. So, you know, everything looks as it would if we were standing there on the ground. And if we take the coastal zone layer now, and I just overlay the boundaries, so we're not looking at the colors anymore, we can see how much complexity there is within some of those habitat patches or land cover patches. So in the suburban areas, we can see the complex mixtures of housing and garden, as we would expect. And then in the urban green space class, we can see that that's also made up of areas of open grassland or pasture or parkland, wherever these classes are here, but also areas of woodland, etc. So there's various different habitats there. And then on the golf courses, for instance, perhaps more strikingly here than out on Northbound Island, we can see the different components of the golf course, the fairways, the greens and the trees, etc., which make up that feature. But what we can do is we can just quickly change that Sentinel image into false color infrared format. So I'm just going to change some of the bands here. I'm going to put the near infrared band into the red color, and then I'm going to put red into the green color and green into the blue. Got that right? So if we apply that, yeah. So this gives us a much clearer view of where the vegetated surfaces are, and you can see that in the suburban here, the vegetated gardens and tree-lined roads, etc., are all now appearing much strongly as vegetation reflects very strongly in the near infrared. So if we use information from that band, then we would get a much stronger vegetated signal. And if we move over to Northbound Island now and also take a look in more detail at the intertidal area, so turn some of these off quicker, we can see that we have quite complex patterns going on here. So these are salt marshes here, and we can see the salt marshes are dissected by networks of creeks. There are different brightnesses of red, if you can see on your screens, and some kind of paler green areas, which are different types of vegetations or densities of vegetation. And if we look on the mud flats here, we can see this kind of red character. This is probably algae or seaweed or possibly pioneer marsh developing on these mud flats. And so it's given us an indication that things are changing in this landscape. And I think if we zoom out slightly and then remember that the line work, the lines were actually produced for 2018, and this image is from a few days ago. So I think, remember the date actually. It's yeah, it's sometime in April. So we can see here that this is a very quick indication of how dynamic the coastal zone is. You can see that the position of the beach or the extension of this sort of sandbar here has sort of changed over time, and there may have even been some erosion or washover of beach materials here onto the salt marshes, etc. So very quickly, by comparing a thematic product at one point in time with an image that's been collected more recently, we can immediately start to pick out changes and things that we may need to consider. Is this a permanent change? If we look at multiple images over time, we can then say something about, are these changes linear in fashion, or are they cyclical, or maybe they're episodic? Nothing changed until a particular storm event, which then reshaped. For instance, this sandbar here could have been reshaped in a particular storm event, etc. So it's really important that we can take these thematic layers, which tell us something about the status of the landscape, and we can add in then this effectively dynamic information from the satellite imagery using multiple images or comparing historical maps to current imagery. And one useful thing we can do very simply with the satellite imagery is convert it actually to a vegetation index. So a vegetation index is a single layer which tells us something about the density, health or character of vegetation. And it uses, as I said, the vegetation reflects strongly in the near infrared but absorbs in the red due to chlorophyll. And that separation, that difference in reflectance is a good indicator of vegetation density and health. So if you've worked in Earth observation for any length of time, you'll undoubtedly have heard of the Normalized Difference Vegetation Index, which exploits that difference in order to calculate this indicator that we can then use for vegetation studies. And we have access to that also within QGIS. So I'm going to do it. I'm going to do it manually, so to speak. So we have our image already loaded in here. If we go to the Compute Raster Statistics, the second plugin that I installed. No, sorry, no, wrong one. So if we go to the raster calculator, sorry, this is already in part of the QGIS application. So, and we can see here that it's listing the various raster bands that we have there. Ignore the NDVI because I've already calculated it. But it shows us there that we have these 4 bands from the Sentinel-2 10-meter data. Band 4 is the near infrared and band 3 is the red. So using this tool, we can very quickly then generate an equation. So we know that NDVI is the near infrared, that's band 4, minus the red, which is band 3. And to normalize that for different viewing effects and atmospheric effects, we also then just divide that difference by the sum of those 2 bands as well. So we're just going to add in band 4 and band 3, close that off. And if we ran this process, then it would take those bands, it would do that band mathematics and return to us an image with a single layer where the result of, for each pixel in that image, the result of that calculation will be present there. And this ranges from 0 to 1, sorry, -1 to 1, with vegetation having values much closer to 1 as the difference between the near infrared and the red increases. But I can say I'm not going to run that because that'll take a few seconds. But what I can do is I can actually show you that layer as I've already calculated it. So if I just toggle between those 2, so you can see the sort of red areas now are becoming much brighter because they have a higher density of vegetation present in them. And straight away we can see much more detailed patterns now on these salt marsh surfaces. So we can see those dissecting creek channels there. They show up because they are either wet mud or maybe with some water in the bottom, and that gives them a very low NDVI value, whereas the marsh surfaces have a much higher value there. And we can see these grasslands, which look quite well managed, possibly fertilized areas here, that they have a very bright signal because they have a lot of biomass on them, a lot of vegetation there. So that's given us a very strong NDVI value there. So that's, again, we can look at these polygons now from the past and say, okay, could these be edited or adapted, or can we find out some additional information about those? And this is where we kind of use our Raster Stats application. So we can take this this little process, this little plugin that we've got here, and it allows us to, we want some general statistics this time. So we take this, take the NDVI layer, and we want to calculate the values for each of these individual polygons. So what we want is a statistical value of NDVI, such as mean, standard deviation, etc., for each of these polygons. So we then choose the Clontarf Coastal Zone 2018 layer, put that in there, and then we choose an output file and then run it, and it generates a CSV file, a table file, which then contains the values for each of the polygons. So each row in the output gives the results for a single polygon, and then we can use that to find out what those statistical values are, and then start to compare polygons. Again, I won't run that because that'll take a few seconds, and you know, I don't want to risk this all falling over and having to start again. But so what I've already done is actually I've prepared an Excel table from a previous run of that, and if we just toggle on the inquiry cursor here. So if we look at this, I'm looking at the yellow outlines here. If we just highlight one of those in this sort of viewer here, we can then get the attribute information for those objects. So we have an object ID here, and we can see that the, sorry, let's just make this slightly bigger. We can see here we have the different levels of the nomenclature, which Anna talked about, so levels 1 to 5. And so we have, this is salt marshes here, so this is 721 or 72100 at level 5. And by having this ID here, we can then find the results in that table of statistics that we've just generated. So I'm just going to flick that on now, and you can see here, so the columns in the table are the zone ID, or this is the object ID of that polygon. And then we have the mean, median, standard deviation, variance, minimum, maximum, etc. For each of those polygons. And you can see the different sizes of polygons will give us a different pixel count here. So these will be quite small polygons, whereas these are quite large. And if you remember back to that polygon here that we're looking at, so this is 238576 is its ID, and then if we go to this Excel table 238576, so this row here, this top yellow row, represents the NDVI statistics for that polygon, and we can see that it has quite a high mean value of 0.32, which is suggesting it's vegetated, and then but the minimum to maximum ranges between -0.15, so that will be those water-filled or wet mud-filled creeks, through to 0.67, which will be where the densest vegetation is present on the marsh. And then if we compare the other, if we go and look at the other effectively back barrier marsh polygon here, this is 238578. So this is it's kind of the extension of that, which has been divided by the road here, which gives access to Northwood Island. And this is our second yellow polygon down here. So this is, and what we can see here, that the mean now is significantly less. So this is 0.13. But if we look at the minimum, maximum, they're not very different. So it's showing that there's the ranges of NDVI present in that polygon are very similar. So similar types of vegetation densities, and because they're both salt marshes, sort of habitats will be present there, but it's actually then more to do with the proportions of different habitats. So we can see that if we go back to the map here, this polygon now includes this area which is become beach, excuse me, or exposure of sand here, and there's also some slightly darker areas within here as well, which I'm not sure of the exact cause, but then it just shows that we have different character within here, even though they have the same range of different NDVI values. The mean value is also then much lower as well. So it's because it's doing a summary of all the values within the area. So if we go back again, and then if we look at this, so if we now look at this this area on the far side, this is sort of sandy beach area here. This is 238577. So if we flip back to the table now, we can take a look at that and see that that's much more like a beach. That's actually got a lower mean value, and but it does obviously clips the polygon clips some of the more vegetated areas of the sand dunes here, as it's given us a slightly higher value of the maximum value here, but its value is still its mean value is still quite low. So we can very easily then, using these sorts of tools, so we've taken data sets that are freely available on the WEkEO, we've loaded them into Qgis, we've run some very simple processing, both geospatially and raster processing, to pull out information from those different layers, presented it in quite a few different ways. You could actually, from any of these plots here, you could then do histograms or pie charts, excuse me, or these ones. You could then cluster the polygons by their mean vegetation index, etc. So there's lots of onward processing that you could then do based on this data that's available within the WEkEO and the tools that are available through this free and open access the GIS system. And as Stefan said at the beginning, there's also tools available within WEkEO itself through things like Jupyter Notebooks. And if you look back through the presentations, webinars that have already been given, there are examples being shown there of how Jupyter Notebooks are used to do some of this kind of processing. So I think I'll leave that there for now, if that's okay with everyone, and I'll leave the floor open for any questions.
Thank you, Jeff. Thank you so much. Fascinating presentation, because it shows the power of the combination of Copernicus Land Monitoring Service products that are there with Sentinel imagery, which in the case of Sentinel-2 with 5 days revisit, are able to develop time series and to make comparisons over time. One point I wanted to make is, so all of our previous, most of our previous webinars have been using Jupyter Notebooks, so using the cloud infrastructure made available by WEkEO. Today, to show that you can also process the data available in WEkEO by downloading it and ingesting it into any GIS software tool. I wanted to say that, so you can do it in the cloud. If you want to do it with Qgis or any other GIS program or software, you can also do that in the first payment plan. You can if you have a license of obviously a propriétaire tool, or if you just are a user of Qgis, you can reproduce the same process in the cloud, because when we're talking about Sentinel-2 and CLMS data sets, they're, I would say, relatively light, but for similar processes where you would want to use, for instance, Sentinel-1 synthetic aperture radar tiles, then you're talking about tiles that are way more than 1 gigabyte per tile, and obviously the advantage of using cloud processing is very large. So we can now move to the question. There is one question that was asked by Rahul Sharma, and he was answered by messaging kindly by Anna, but he was asking about sediment budget retrieval methods. And Anna basically told him that sediment transport are a user requirement, a cataloged user requirement for the evolution of both the CLMS, Copernicus Land Monitoring Service, and Copernicus Marine Environment Monitoring Services. There's a roadmap that has been developed and is available online. So those who want to look at how the service will evolve over time can look at that roadmap. I just posted the link to the document in the chat. Then there's 2 open questions. The first one is from Gianluigi Renzi, who's asking, how can a public institution or local authority purchase WEkEO Premium Advanced Services? Are these services available for purchase on the electronic market, like e-procurement, or are there commercial enablers? Have you already had other cases in other parts of Italy or Europe? To be honest, I don't know the answer. That's a very good opportunity to help us enrich. It may be in our FAQ. You can have a look on the website. It might not be because it's a very specific question. And I strongly encourage you to send an email to support@wekeo.eu, because I'm personally also interested, as local and regional authorities are a very important user reservoir for Copernicus products in general. But for coastal, local and regional authorities, there's quite a lot of applications that can be developed using the coastal zone data sets from CLMS. So I encourage you to send your question by email to the user support, and we'll make sure it's answered because it's indeed an important, but with the procurement rules that local and regional authorities have to use for purchase above a certain amount, at least in Europe. That's a question that I think it's important that we know the answer to that, and we indeed work on making processes available so that there's no need for a tender to all of a sudden have a city or a province or a region or an agency basically buy a premium license for WEkEO. Then there's a question from Sofia Bilbao. Like you mentioned, the trade-off between resolution, accuracy, extent between ground data and satellite data is very important. What are your thoughts on creating a workflow that allows the access to a public hub with other people's data sets, for instance, data sets used to train an AI workflow to extract shorelines, or for instance, ground measurements that can be used to validate other results, hence being more rigorous and complete? Jeff, do you want to take that one?
Yeah, I mean, I'm not exactly sure what the policy of WEkEO is in terms of hosting data sets that don't come from the entrusted entities. That's maybe
I can well, on that particular question, the answer is very easy. You can upload to your Jupyter notebook whatever ancillary data. It can be anonymized location of mobile phones if you're looking at movements of population in a national park or on a coastal area. It can be statistical data sets from other sources. It can be in situ data from in the case of coastal zones in particular on the marine side from EMODNet, which is the European portal for accessing in situ data, marine in situ data. You can basically upload anything and then run your routine in the Jupyter notebook.
But are they excuse me, are they then made publicly available, or is that only within your own workspace?
It's within your own workspace, yeah. but I guess technically the workspace, a public workspace, could be in theory at least open.
I think the issue then of making them openly available would then be issues of quality and licensing around those layers. I mean, it's sure. Given the example of shorelines is a great one. I mean, Anna will probably be aware of this from the development of the coastal zone product, that getting an agreement on what exactly was the shoreline. And then migrating 10 kilometers inland from that was quite a debate, because depending on where you are in Europe, if you're in a macrotidal area where you have large changes in the position of the actual water's edge during a tidal cycle, then you could have dramatically different buffer regions that you wish to map. So that's a kind of ongoing debate, and I think it's perhaps more important to think about, you know, whether you see the shoreline as the actual water's edge, or is the shoreline a concept which refers to the coastal zone itself. So, I mean, there are plenty of lines, the high watermark, low watermark, etc. And it then becomes very case specific and domain specific, but it's certainly an interesting debate about where that falls. So, Anna?
Just yesterday, by chance read very quickly, I can't recall what it was, but something that CMEMS is also looking into shoreline.
Yeah.
There was a meeting yesterday with the EA and also with CMEMS where they discussed coastal dynamics, linking to one of the questions about sediment budget and all that. That was also addressed. I was not there because I was at the doctor, but indeed, yeah, it's in debate indeed.
Yeah. So I mean, by default, it's very dynamic. You know, depending on how you choose it. So even if you said the position of, say, the vegetated edge, for instance, that is over longer time scales, even that's dynamic as areas erode or sediment or the sedimentation and new vegetation appears. So, but yeah, that's an interesting question. Thank you.
Thank you, Jeff. Thank you, Anna. Before we go into the other questions that are more generic nature, for the members of our audience who are not in Europe, I would like to make a few comments. When we said in the beginning, the coastal zone product is available over Europe, this is not the EU. These are the 39 member states of the European Environment Agency. So it includes Turkey, it includes the countries of the Balkans, etc. So it's not only the member states of the European Union, first point. And second point, nobody asked the question, but what about developing similar applications in countries that are outside of these 39 member states of the EEA? Well, there is a global land product, but it has a much more coarse resolution. Then there are some experimental products with less classes and no guaranteed quality level. For instance, the European Space Agency has sponsored the development of a world land cover map at 10 meters extracted from Sentinel-2 data at 10 meters per pixel accuracy. So there are some proxies, but obviously they're not as elaborate and they do not have the spatial resolution of the CLMS products.
I think, sorry, following on from that, Stefan, I think we can say that the processes that have been applied can be rolled out now to other parts of the world. It's just some of the data sets may be commercial. Yeah. So they could be generated for any other parts.
But for instance, in the United States, obviously there's no Copernicus land cover map other than the global land one at the coarse resolution, but there is a USGS detailed land cover map that can be used to perform the same kind of analysis. And I suppose that countries like India, for instance, might have their own nationwide or statewide land cover, land change data sets that could also be used. Okay, other questions. Can you let us know any upcoming important event like this? Question from Ravichandra Hassan Manjunatha. I will indeed present the calendar of the upcoming webinars in my concluding remarks. Rahul Sharma is asking if there are any opportunity to do internship or collaborative work with WEkEO. Internships at WEkEO, I would say no, because WEkEO is not even a company. It's just an association of 4 partners to deliver a service. So internships at WEkEO are not possible. There might be opportunities for internships at some of the participating organizations. Most cases, internships are reserved, but not all of them, to EU citizens or associated states. But there might be some opportunities. I don't know of any one in particular, but you could write an email to support@wekeo.eu explaining what kind of internship you're looking for, and we would be happy to forward that to a few organizations that we are working with. There's a question from Gianluigi Renzi. At the same time, the monthly assembly of the relays Copernicus was also scheduled. It's also possible to check that there is no overlap of Copernicus events in the future. Well, being involved also in the Copernicus support office, I had to choose between the two. I do agree that it would be better if we could synchronize things. On the other hand, there tends to be now with Cassini, the hackathons, the matchmaking, the global EU platform on space, the global action it's called. There's many things that are going on. The entrusted entities like Mercator for marine, like ECMWF for atmosphere and climate change, all organized events. There isn't a central procedure, a centralized procedure that would allow to do it, but I do take the point that for future webinars, we should avoid to place them on the days where Copernicus Academy and Copernicus Relays have their monthly video conference. Point taken. We haven't, well, I must confess, we hadn't thought about that. I see no other questions in the chat. We have another 6 minutes before closing. Anna, would you like to give say a few words before I introduce the next webinars? Not. Okay. Well, I think it was very interesting, at least from my perspective, to see a different use of WEkEO instead of working with Jupyter notebooks, which is, I would say, maybe a bit more, requires a bit more technical knowledge than at least basic usage of QGIS. It was interesting to see the other side of the coin and the more traditional Earth observation analysis. And again, this combination of frequently updated satellite imagery and existing very high resolution land use products. So that was quite interesting. So let me move to my presentation on the next webinars. Let's try and do it like this. Okay. I share my screen. This should work, hopefully. So our next events. Our plans until the summer include webinars dedicated to similar types of applications, but in different thematic areas than what we saw today, but also more generic ones. Again, they're aimed at both beginners and experts. We try to find a middle ground between super experts and people who are just trying to become acquainted with the possibilities of developing applications. Our webinars will be running until the end of June. There's 4 thematic ones provided by experts from the various participating organizations, and one will outline, there was one last year already, but we will dedicate one to the new products available in WEkEO, because as the Copernicus product offering is constantly evolving, it's interesting to show that there are some new products that, well, weren't there a few months ago, and now you can all of a sudden access. A good example, for instance, is our pan-European snow and ice CLMS product. That is a recent addition. New products are coming up, products on phenology, products on ground movement, etc. So we will present those. This is the calendar. In mid-May, we will discuss applications for sustainable tourism, focusing on the use of Jupyter notebooks to look at water quality, water transparency, etc. But we'll also introduce other data sets available that can be used for tourism applications. Air quality is an obvious example with the Copernicus Atmosphere Monitoring Service data sets. Winter ski resorts is another example with the snow and ice data set that I discussed earlier. So we will talk about tourism. On the 2nd of June, we'll try to do a little overview of all the data sets included in WEkEO that can be used for supporting the EU Green Deal and all the associated policy and measures. On 16th of June, we'll talk about how to use WEkEO for applications using artificial intelligence, machine learning, and similar processes. And we'll end up on the 30th of June with again, this presentation of the new products available in the catalog. So our next appointment is on 19th of May at 10:30 to discuss the applications of WEkEO and Copernicus data to sustainable tourism. Last but not least, to those who are into Jupyter notebooks, I'd like to highlight the fact that there's an ongoing Copernicus WEkEO Jupyter notebook competition, and I will invite, if he is present, my colleague Ionut Dragan to tell us a few words about this competition. It's interesting. The price pool is 5,000 euros, which is quite high for such an endeavor. So Ionut, if you're there,
yes,
the floor is yours.
Yes, thank you very much, Stefan. So very quickly, maybe just to summarize what's the whole idea behind this competition. Firstly, this competition is funded by the Copernicus program and has been developed as a joint project between EUMETSAT, EC, MWF, Mercaton Ocean International, and the European Environmental Agency. And basically, we just want to invite people that are working in the EO ecosystem to share their knowledge and build a notebook that can help others to start their journey with the Earth observation data. Because as we know, this data it's quite big, but maybe for some that are at the beginning, those notebooks can be, let's say, can make a serious difference in starting a career or even unleashing new insights about our Earth. So as Stefan said, the applications are open. So if you want to check out more, go on the website on notebook.wekeo.eu. And yeah, we also have a prize pool there, which can be very interesting. Thank you.
Thank you, Ionut. There's one last question that we can still really quickly take. The question is, it's been answered in writing, I believe. Which the question was, can we upload self-generated data like station data while sharing the developed web application? Well, if it's sharing with the outside world, the answer is yes. As I said, you can upload nearly any kind of digital data into your Jupyter notebook. Whatever the format, you can process it, and then the result you could display in a public web application. That is perfectly possible. There is API. You have APIs where you can constantly update even data from outside the WEkEO product catalog, and you can also re-export the data to display it on a website. That is possible, and our colleagues from the user support service are available to assist you on the IT side of things, on how to perform the various operations to make that work. So that is it with the questions, I believe. So again, we hope to see many of you on 19th of May to discuss tourism applications. We're very grateful for the large participation, and we thank you again and remain at your disposal through the user support service to answer any questions about WEkEO in general, or questions about today's presentation. If they come up to your mind after we close the session, we'll definitely be available to answer them in writing. And as Jeff is a distinguished member of our expert team, you'll get the answer directly from the horse's mouth. Thank you again for participating, and we look forward to seeing many of you on 19th of May. Goodbye.
Bye.
Goodbye, everyone.
Goodbye, Anna.
Oops. Sorry. Thank you.